everyone, once again welcome back to my YouTube channel. This is Unit 1 Physical World and Measurement for class 11th, and we are discussing the various topics of this unit. In the previous video lecture, we talked about dimensional analysis, where we discussed what the dimensional formula is and we derived the dimensional formulas for various physical quantities. In this video lecture, we are going to discuss three main topics, that is principle of homogeneity. We will also talk about the different types of variables and constants, and we will discuss the limitations of dimensional analysis. So first of all, let us talk about the principle of homogeneity. According to this principle of homogeneity, if we are having a dimensional equation such that on the two sides, that is left hand side and right hand side of the equation, we have expressed any physical quantity in terms of fundamental quantities, then the dimensions on the left hand side of the physical relation are equal to the dimensions of the fundamental quantities written on the right hand side of the physical relation. So that means, according to the principle of homogeneity, the dimensions of fundamental quantities on the both sides of a physical relation are always same. On the both sides of a physical relation are always same. So let us understand this concept with the help of an example. So let us say we are having a dimensional equation. In this dimensional equation, we have written the dimensions on the left hand side of the equation such that m raised to power a, l raised to power b and t raised to power c is equal to m raised to power x, l raised to power y and t raised to power c. In this case, according to the principle of homogeneity, the dimensions of mass on the left hand side are equal to the dimensions of mass on the right hand side, that is a is equal to x. Similarly, dimension of length on the left hand side of the equation is equal to dimension of length on the right hand side of equation, that is b is equal to y. And similarly, dimension of time on the left hand side of the equation is equal to dimension of time on the right hand side of equation, that is c is equal to z. So this principle of homogeneity will be used when we will be discussing the uses of dimensional analysis. So now we will talk about the different types of variables and constants which exist in physics. The first point which we will discuss is dimensional variable. As the variable suggests, that the thing which is not constant, whose value keep on changing with time or place. So dimensional variable is that physical quantity which has dimensions, but the quantity keeps on changing. That is why we call this kind of physical quantity as a dimensional variable. So the physical quantities which possess dimensions and have variable value, the values which keep on changing with the time and place, are called variable values. So such kind of physical quantities are called dimensional variables. So there are many physical quantities whose value keep on changing, so these quantities but also have the dimensions. So such kind of quantities like area, if we talk about the area of a room, it will be different. We talk about the area of a park, it will be a different quantity. So that means the value of area is different in different cases, but always area has a dimension. So such kind of physical quantity is a dimensional variable. Similarly, volume of different vessels is different. There are some containers which can carry up to 2 liters, there are other containers which can carry up to 5 liters. So therefore volume varies from container to container. Similarly, velocity, force, work, energy, these are all variable quantities, but all these quantities possess some dimensions. So these are called dimensional variables. Next type is dimensionless variables. So there exist some variables, some changing quantities, some changing physical quantities which are constants, that is their value is fixed, but these variables do not possess any kind of dimensions. While discussing the various dimensional formulas in the previous video, we talked about the dimensionless variables. So there are dimensionless variables, the physical quantities which do not possess any kind of dimensions, but they do have the variable values, are called dimensionless variables. So various examples in physics exist for the dimensionless variables. For example, angle. We can change the angle from 0 to 360 degree. So these values are changing. The value of angle is changing, but it is dimensionless. How it is dimensionless? Because we know angle is equal to arc upon radius. That is, it is the ratio of two similar quantities. So when we are having a ratio of two similar quantities, then it does not has any dimensions. Similarly, relative density, that is density of substance upon density of water at 4 degrees Celsius, again two similar quantities, so it is a dimensionless variable. The third dimensionless variable is strain, change in length upon original length. Then every trigonometric function is dimensionless variable. For example, sine theta. So if you have angle theta is equal to 0 degrees, sine 0 is 0. If you have angle is equal to 30 degrees, sine 30 is equal to 1 by 2. So the value of sine theta is changing. That means it is variable, but it is not having any dimension. The next quantity is dimensional constant. As the name constant suggests, that is the value which is fixed. So there are some physical quantities who have a fixed value. Such physical quantities which have fixed value, that which are constant but they have dimensions, are called dimensional constants. So we can say the physical quantities which possess dimensions but their values are constant are called dimensional constants. So in physics we are having various dimensional constants. For example, Planck's constant. Planck's constant has a value 6.6 into 10 raised to power minus 34 joule second. So in this case, we are having a fixed value, but it has dimensions as we calculated it in the previous lecture. Similarly, universal gravitational constant capital G. It has a fixed value 6.6 into 10 raised to power minus 11 Newton meter square per kg square. That is, the value is constant, but it has the dimensions. Also, speed of light in air or vacuum. It is 3 into 10 raised to power 8 meter per second. That is, the fixed value of speed of light in air or vacuum is there, but it has dimensions, that is m0, l1, t minus 1. So such physical quantities having fixed values are called constants, but these possess dimensions. Therefore, these physical quantities become dimensional constants. The last type is dimensionless constants. So all those physical quantities whose value is fixed but these quantities do not possess any kind of dimensions, then these quantities are called dimensionless constants. So we can say the physical quantities which do not possess dimensions and the value of such physical quantities is fixed are called dimensionless constants. Which do not have dimensions but have fixed value, that is constant value. So there are so many numbers, that is, there are pure numbers which have constant values, but these numbers do not possess any kind of dimensions. Therefore, all the pure numbers are the examples of dimensionless constants. For example, 5. 5 is a fixed value, but it does not has any kind of dimension. Therefore, pure numbers are dimensionless constants. And similarly, pi, it has a fixed value, but it does not possess any kind of dimension. Therefore, it is again a dimensionless constant. Now we will talk about the limitations of the dimensional analysis. There are many uses of dimensional analysis, but it is important to know the limitations of dimensional analysis first. So the first limitation of dimensional analysis is that any constant which is involved in a physical relation could not be determined with the help of dimensional analysis. That means in any kind of relation, like in the relation of kinetic energy, that is half mv square, the constant half could not be determined with the help of dimensional analysis. So dimensionless constant involved in the physical relation cannot be determined. The second limitation which we have with the dimensional analysis is a very major limitation, and this limitation says that we are having three major equations in mechanics which help to study motion, that is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. These three major equations could not be derived with the help of dimensional analysis, which is one of the major limitations of dimensional analysis. So dimensional method fails to derive the relation v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. The next limitation of dimensional analysis is that it fails to give information about any trigonometric function, logarithmic function, or exponential function involved in a physical relation. Also, it fails to determine the complex numbers in the physical relation. So if we are having a fixed equation, if we are having an equation, or we are having any kind of relation existing between the physical quantities, in that case dimensional analysis fails to determine trigonometric, exponential, then logarithmic, and various other complex quantities which are involved in that physical relation. The fourth disadvantage or limitation of dimensional analysis is that there are only three fundamental physical quantities which are involved while we use dimensional analysis. These three fundamental quantities which are involved are mass, length, and time. So if we are having any relation which involves any other independent quantity, such as temperature, such as intensity of light, or quantity of matter, so in that kind of relation, dimensional analysis fails to develop such relations which involve other independent fundamental quantities. So since only three fundamental quantities, that is mass, length, and time, whose power can be compared on the two sides of the equation, therefore dimensional analysis fails to derive the relation involving more than these independent factors. The fifth limitation which we are having with the dimensional analysis is that it does not give any information whether the given physical quantity is a scalar quantity or a vector quantity. So in physics, it is very important to describe the physical quantities as the scalar quantities or vector quantities, but dimensional analysis does not give any kind of information that the physical quantity involved is a scalar quantity or it is a vector quantity. Again, it is one of the major limitations of dimensional analysis. It does not provide the information whether the quantity is a scalar or a vector one. The last limitation of dimensional analysis is that there are some physical relations which are dimensionally correct, but when we look into the relation quite deeply, we find that these dimensionally correct relationships are physically wrong. So dimensionally correct relation may not be physically correct. So as for example, I told you that kinetic energy is equal to half mv square, but if you write the kinetic energy as mv square only, in that case the relation will become dimensionally correct, because half will not be determined with the help of dimensional analysis, but otherwise the formula is wrong. Similarly, the equation v square minus u square is equal to 2as is the correct relation, but with the help of dimensional analysis we will find v square minus u square is equal to as is dimensionally correct. So therefore we can say that dimensionally correct relation may not be physically correct. So these are the limitations of the dimensional analysis. In the next lecture, we will discuss the first use of dimensional analysis. I hope you have understood all the concepts which I have taught you today. If yes, then do not forget to press like, subscribe and share button, and do press the bell icon in order to get latest notifications on my videos.